So guys, for this project, first you are going to need a wooden board, and after that an aluminium foil. The size can vary, of course, and a paper. I'm using an A4 size sheet, the printer sheets. After this, you're going to need this. So this, you can see, is nothing but a simple metal piece with this big space, or like this big continuous length, something to do like this. Okay, and this is the plastic that I'm going to use as insulation for protection from electrocution. So I will have to place it on this plastic piece somewhat like this. Okay, this is a high voltage wire. You can see how thick the insulation is, and I got it from a flyback transformer. Okay, so place it like this, and that's it. So guys, now comes the part of placing hot glue on the metal piece and the plastic so that they both stick to each other. As you can see that it is stuck pretty strong. So let's move on to the next step. Now guys, you're already familiar with this inverter circuit of mine. I made it a few weeks back, and I'm going to use this very circuit in this project. This circuit is going to produce around 500 volts, and the voltage is going to appear on these two terminals, and it is going to be AC. Now I need to elongate one of the wires. So here I have this blue wire which I'm going to connect to the blue wire. Okay, after that, this what you see is a case from an old DVD drive, computer DVD drive. Okay, so the blue wire terminal will be connected to the blue DVD drive, something like this. Yeah, so this also done. Now guys, after doing that, keep it on one side and bring on this old A4 sheet and the aluminum foil, and this DVD drive case will be placed below the aluminum foil sheet, something like this. After that, all we have to do is place the A4 sheet over here, and then comes this part. So this wire will be connected to the left out white wire. Now guys, at this point I'm going to place some insulation tape for safety, because we are working here on high voltage. Here I'm going to write let's write B. Okay, yeah, okay, you see here it's written B. Connect this positive to the positive and negative to the negative. Let's hope it works, and I'm going to use this black insulation tape to hold this, and this is the sheet. Let's try and hope it works. Yeah, well, I think that the voltage is not high enough. I will have to increase the voltage. Now guys, this is the joint over here. Okay, so I have disconnected the wires, and here I have a clip, and the other end will be connected to the high voltage terminal of the transformer, and that is also done. Okay, so trying it once again, holding this piece, now this, and go. Whoa. Well, it didn't work as expected. Let's discharge it first. Well, the bad news is that yes, there is harm to the aluminum foil. Let's remove it and do it directly this time. Let's go for T. Trying it the second time. Okay, get ready for the show guys. Let's hope it works this time. Again, not working as expected. Now guys, here I have the syringe and some water in it, rainwater to be specific. Let's try it this way. Okay, so I've written M. Now let's keep it like this and try it once again. Now comes this part. Okay, keep watching it. Now it looks somewhat close to M. So I think we will have to use some conductor which is going to create a path for the high voltage to follow and make the marks to create the burnt letters. Now I'm going to write Mr. and electron. Okay, done. Now let's keep it inverted. Okay, keeping it like this, and now comes the typing. You see, it is so easy this way. Okay, I think the water for T dried out. Okay, I will invert it. Then you might see it better. You see Mr. Electron MR, Mr. ELEC. Now the T just missed, R is inverted, O and N is again a disaster. Well guys, initially I was going to write with salt water, but then I realized that I have something even better, sulfuric acid dilute. Okay, so I'm going to write with that. Okay. Wow. Oh, that is brilliant, guys. Wow. Now, guys, for the final time, I thought why not use a screwdriver? In this video, I'm going to teach you how to use this part from an old photocopy machine. The motor installed at the back of this part is a brushless DC motor with a power rating of 120 watts and voltage of 24 volts DC. And the best part is that it also has the driver PCB installed with it. Now, in many of my previous videos, I showed you how to utilize the motors from an old photocopy machine and run them at high speed, high RPM with an external driver, BLDC driver. But in this video, I'm going to use the PCB installed on this very machine and I'm not going to use any external driver. Well guys, here as you can see the back part of this machine, and it contains the PCB which looks like it's in good condition, and the motor is also fine. You can see that it is very smooth, and that's the heat sink that is placed on an IC. So now you must be thinking where to connect the wires. So the wire connection part is here. You can see there are 4 pins, 1 2 3 4, and it says 24 volts PG log and S/S, but there is no ground terminal. Now guys, the machine from which I salvaged this part was really old, so to connect the wires I will first remove the oxidation layer on the terminals. Now guys, this what you see is a 6 amperes diode. It is optional just for safety. If you don't connect this, then by mistake if you interchange the positive and negative terminals, then there could be a short circuit which might damage your PCB. So for safety I'm going to connect this diode. It is optional. So this side of the diode, not the gray side, the other side is positive, so it will be connected to the red wire. Okay. Now let's connect the wires here. So I'm taking out the red terminal from this slot, okay, and this green also from this slot. Green is going to be your negative. As for the positive, I will connect it to this 24 volts pin. So let's first place some flux on the 24 volts pin. Yeah, done. And on the diode terminal also done. Now guys, the positive has been connected, but there is still left this S/S terminal. Okay, take another wire and connect it to the S/S terminal. Yeah, done. And then fold this wire and connect it to the positive terminal of the diode. negative terminal of the diode or positive input for this BLDC PCB. Now comes the negative terminal. So guys, take the green wire and bring it out from the same slot as the red wire. Okay, it is really tight, which is good. And here we have the green wire coming in from here and red wire. I've given a loop so that it is stiff and does not pulse the terminal with the diode. So with that being said, let's connect this wire, okay, to the negative, which I think it is. You see here it is showing one negative terminal, and this negative is also coming from here, and this is also the negative. So seems like this is the ground. Let's do that because there is no other ground option given, so I have to go for this one. Okay, this one seems easy. Yeah, done. So guys, finally here we have our fully working operational BLDC motor. Let's test it and see how fast it runs. Now guys, this is a 12 volts UPS battery. You can see that this terminal is almost gone, and it's a very old, almost 5 years old 12 volt 7Ah UPS battery, with which I'm going to try and run this 24 volts motor. Now guys, note that I'm powering this motor piece with only 12 volts input supply. Now guys, I've kept it held in one place with the help of this table vise. Let's move it like this. You can see how smooth it is running. And the best thing is that there are no bearings, okay, and still it is really smooth. So now it's time to run it with the help of this battery. So the green wire, I've connected it to the negative terminal of the battery, and now comes the positive. Okay, go. You see, it is running pretty good, and it is really safe because I have connected a diode in series. So if by mistake I interchange the terminals, this driving board PCB is not going to get damaged. Cool, right? And I'm running it at just 12 volts DC, not even 24 volts. Let's try and stop it here. The torque is obviously going to be high. Yeah, it is really strong. Yeah, it is very strong. Oh, the gear marks. As you can see how strong this motor actually is. Once again. This what you see is an expensive 100 watts LED light Lustreon. The operating voltage range of this LED light is 110 volts to 220 volts. And in total I have 10 pieces of these. So when I connected this one, you see it burned out. You see this was some kind of capacitor and it blew. So after that I tried operating another LED panel, but at lower voltage, like reducing it to 120 or 130 volts, and it worked perfectly. So guys, when I investigated the problem, I found out that the voltage that we get from our home socket is much more than just 220 volts. It is as high as, you can see, 240 volts AC, because of which my LED light got destroyed. So guys, to eliminate this problem and safely operate my expensive LED lights, I found this solution. Now guys, the first question that I want to ask you guys in this video, and you have to answer it truthfully in the comments. How many of you knew that even 120 volts Zener diodes exist in the market? And this one is the second piece for this circuit. It is MJE13009 power transistor with a voltage rating max of up to 400 volts. So guys, starting with the first part, which is the oxidation removal on the terminals of these two components, okay, the rectifier and the power transistor. Okay, so for that I'm going to use this Dremel tool, mini Dremel. So guys, after that, place the rectifier in such a way that the positive terminal faces you, okay? So now comes the soldering part. So guys, you see how beautifully I've placed it finally. It is shiny. I can almost see my finger reflection. Okay, it is perfect. Now guys, after this being done, remove it and then take the power transistor. And I have one more empty arm over here. Place it like this and then fold the terminal, the emitter one and the base one. And the collector terminal will remain as it is. Now place some flux for better soldering. Okay, yeah, that is good enough. So here as you can see guys, the positive terminal of this power transistor is in direct contact with the positive terminal of the bridge rectifier. This is the Zener diode that I'm going to use for this project, as I have already showed you. It is 120 volts. So this is positive, that is for sure. Collector is positive and this terminal from the rectifier is positive, but the Zener diodes are connected in the reverse direction, and for a diode the silver side represents the negative. So the negative terminal will be connected over here. It is going to be something like this. So let's place some flux on this terminal also. That's done. Okay, so starting with the soldering. Yeah, you see a perfect connection for the three pieces: the rectifier, the transistor and the Zener diode. Now the positive terminal of the Zener diode will be connected to the base of the transistor. Okay, like this, and done. So guys, after completing, the circuit will look something like this. Okay, pretty good soldering, and everything is in place exactly how I want it, and the two terminals are separate. Now comes the wire that I'm going to use here. Well, this much length is good enough. Now guys, here as you can see that this one terminal coming out from the power transistor, this one is the emitter. So to this emitter terminal I am going to connect this green wire. Now guys, after that being done, all that is left is connecting the connector cables. Okay, so let's find the AC terminals first. You see this is positive, this one is like a sine wave sign, so this is AC, and its diagonal opposite is also AC. So to the AC terminals I'm going to connect the blue terminals. Both the blue wires will be connected to the AC. So these blue wires are for 220 volts input AC supply, which is actually 240 volts as I showed you, and the remaining terminal, you see, that is the negative terminal. This is positive, you see, of the rectifier, so its diagonal opposite is the negative, and done. So these two, the green and the green, are going to be the output terminals, and the blue are going to be the input terminals. So let's check it and see how it performs. So guys, the heatsink has also been connected. Now let's try it. Now guys, this is the 240 volts AC supply I am getting. So let's check it before operating. Now here as you can see that it is 242.8, almost 243 volts. For safety purposes I have turned off the supply, and now I'm going to connect the blue terminals to this pin directly. Okay, the supply is turned off. Okay, so I'm going to turn on the supply. Now let's measure the output at the two terminals. And as you can see that we are getting only 117 or 118 volts, which is safe for our supply. Yeah, 117 or 18. Perfect. Even 116. Okay, so guys, now let's connect this 100 watts LED. You see here it is showing 110 volts, 100 watts. So guys, the terminals have been successfully connected. Now let's turn the supply on. Whoa! Working really nice. Great. Turned off. Let's turn it on again. And we have a very safe, perfectly working circuit. Well guys, I also wanted to try and test this powerful large DC motor, since the output from this circuit is DC, so it can work for that part as well. Okay, so the connections have been made to the circuit, you see, and this is the earth wire, not needed. Now let's connect the terminals of the mains. Although it is turned off right now, I will turn it on after the connections. So guys, the connections have been made. All I have to do is turn the supply on and it should start working. Okay, so keep watching the motor, guys. Go. Well guys, how foolish of me, because I never thought that the torque was going to be so high. But the good thing is that the circuit built was very strong, because of which it didn't get damaged, although the transistor is bent a little bit, but the sheet is damaged, you see. This was a little smaller motor than my normal large motor, so I thought that the torque is not going to be high, and also I'm not going to give it its full input voltage. But as you saw, that was really high and I was wrong.